You are welcome to today's lesson. We are continuing our discussion on series and sequence, and the subtopic for discussion is arithmetic progression. A sequence is said to be an arithmetic progression, which is also termed as AP, if any term in the sequence differs from the preceding term by a constant called the common difference. In other words, a sequence is regarded as an arithmetic progression if the differences in the sequence are the same. Now let's note that the common difference may be a positive or a negative number. Now a sequence can be defined when we know the first term, which is noted as A, and the common difference, which is also noted as D. So anytime we have a sequence, the first term is always denoted with the letter A, and also the common difference is represented using the letter D. Now let's take a look at an example. This represents a sequence of numbers. Now this sequence of numbers is an arithmetic progression, and the first term, which is denoted as A, is 4. So if you take a look at the sequence of numbers, you can see that the first number, which is the first term, is 4. And its common difference, which is denoted as D, is 3. That is, if I want to determine the difference or the common difference between this set of numbers, I need to subtract the previous number from the next number. So for instance, if I pick the number 7, I'm going to subtract the previous number, which is 4, from it. And that will produce 7 minus 4, giving us the answer 3. If I pick the third number, 10, it means I'm going to subtract the previous number from it to get my difference. And so that will become 10 minus 7, producing the answer 3. If I also pick the fourth number, which is 13, to get the difference, I have to subtract the previous number, which is 10, from it. And that will become 13 minus 10, producing the answer 3. And so you observe that the differences between this sequence of numbers are the same. That is what we call common difference. And so in an arithmetic progression, we expect that the differences between the sequence of numbers should be the same. In other words, there should be a common difference. Let's look at another example. This is a sequence of numbers represented by 11, 9, 7, and 5. And remember, in an arithmetic progression, we are looking out for the first term, which is denoted by A, and the common difference, which is also denoted by D. And so in this example, the first term, which is denoted by A, is 11. And what will be the common difference? We said that the common difference is given by subtracting the previous number from the next number. So when I pick the number 9, I'm going to subtract the previous number, which is 11, from it. And that will give me the difference of 9 minus 11, producing negative 2. If I pick the number 7, it means I'm going to subtract the previous number, which is 9, from it. And that will produce 7 minus 9, giving the result negative 2. If I also pick the last number, which is 5, I'm going to subtract the previous number, 7, from it. And that will produce 5 minus 7, giving us the answer negative 2. So you observe that the differences between the sequence of numbers are the same. And so the common difference here is negative 2. Let's look at the third example. In the same way, we want to test and see if this is an arithmetic progression. And to do that, we need to know our first term. And the first term, as usual, is 8. So A equals 8. And what is the common difference? In the same way, we are going to subtract the next number from the previous number. So when I pick the number 6 whole number, half, I can convert this to an improper fraction as 13 over 2 and subtract the previous number, which is 8, from it. So 13 over 2 minus 8 will produce negative 3 out of 2. In the same way, if I pick the number 5, it means I'm going to subtract the previous number, which is 6 whole number, 1 out of 2, from it. And that will become 5 minus 13 over 2. Remember, 13 out of 2 or 13 over 2 is the same as 6 whole number 1 out of 2. And so when we perform the subtraction, we'll be producing negative 3 out of 2. If I also pick the last number, which is 3 whole number 1 out of 2, which can also be written as 7 over 2, it means I'm going to subtract the previous number, which is 5, from it. So we'll be having 7 out of 2 minus 5, producing the number negative 3 over 2. And so you observe that the differences are the same. And so this sequence has a common difference, which is known to be negative 3 over 2. Now let's take a look at our assignment for the lesson. In this assignment, we have a sequence of numbers 4, 9, 14, 19. And we are to determine the first term, which is denoted by A, and the common difference, which is also denoted by D. Thanks for watching, and see you in the next lesson.